right, hello again. So we are going to continue working through the quadratic function unit. We're going to start with a few examples and basically going through different types of examples and seeing how we can analyze a quadratic function. Okay, so first review the vertex form of a quadratic function. This is the vertex form right here. So this is the vertex form, where it's written in a form of y equal to a times x minus p in a bracket all squared plus q, and where a cannot be 0. We also know the general form. Right, the very first thing that we talked about was the general form. With the general form, there are a few things that, couple of things that we do know. We know what a is and a can do. We know the c becomes the y-intercept, but that's basically it. We will not be able to know what the vertex is. So let's write up what is it that we do know about a vertex form of a quadratic function if it's given to us. We know that the vertex will be p and q. Okay, we also know that the equation of the axis of, actually let's put it, axis of symmetry, that's a line that basically splits the graph in a symmetrical way. It is always the vertical line x equals to p. That's the equation of the axis of symmetry. Okay, and we also know what a is, and a is your expansion or compression factor. Okay, and that's basically it. And of course we know a point on the graph, that's your point xy. All right, so that's what we do know. So when we have the vertex form of a quadratic, we simply can extrapolate all of these information and basically graph the quadratic function. All right, with the general form, we only know that c is the y-intercept, because when you set x equal to 0, that's how you're going to get y-intercept. So the value of c is the y-intercept. The other things we do know is that this a, so the expansion compression factor and the orientation of the graph, is it upside up or upside down? All right, I guess I should say the orientation of the graph, is it in here of the graph? It's the same a as this one, so I guess I should include that as well in both. Okay, so not only the expansion compression factor, but is it if it's positive or negative, what happens to the graph? Okay, it opens upside up, the graph is upside up, or the graph is upside down. Okay, so let's look at, so let me quickly, so if the a is negative, is upside down graph like that. If a is positive, this is a is positive, the graph is upside up. Okay, very good. Now let's go ahead and look at a couple examples. Okay, so we have this example here. The equation is given to you, and we need to write up the information first, all the characteristics of the important characteristics of the quadratic function. So the same thing as we just did. So we're going to go through and do that. So vertex, what is the vertex? Vertex is -1 minus 2 or -2. That's the vertex. We already know that. We can read it off. What else we do know? We know that the equation of the axis of symmetry, I'm going to call it equation of the axis of sim, as in for symmetry, is x equals to -1. That's very useful, because once we know that, we can create the other set of points on the left hand side or the right hand side of the graph, so that we can create the total graph. And the other thing that we do know is that a is positive 1/2, so we know that the graph opens up or is upside up. We do know that. And we also know that is 1/2. That means the pattern of, if you remember the pattern of 1, 3, 5, 7, now the pattern is 1 over, instead of being 1 over 1 up, is 1 over half up, and then 1 over 3 half up. Okay, so this is up, right? And then 1 over 5 and 5 half up will be by half. All right, so let's go ahead and plot vertex first. -1, -2. So -1, -2 is right here. So I'm going to plot that. Very good. The next thing is that I'm going to use the expansion compression factor. So actually, before that, let's just do a dotted line with the actual symmetry. So we know that it is the x equals to -1. That's the equation of x symmetry. The next, we need a few other points so that we can graph it accurately. All right. So we're going to use from the vertex. So this is our vertex right here. So this is vertex -1, -2. So we're going to now do the 1 over, and then we're going to use this pattern right here. So 1 over instead of 1 up is half up. So it's right there. I'm approximating it. Okay, so right there. That's the next point. All right. The next piece, I just quickly expanded the graph so they can see it better. So our next point that you can see, actually what I did, I went back there and make sure that you can see what is happening with that pattern 1, 3, 5, 7. So if we look at the original y equal to x squared, this is the pattern that generates. For if you go 1 over, as in one value of x goes to the right or to the left, you go up 1. So 1, 1. The next one would be 1 over again, but this time y goes up by 3. So that's what the 1, 3, 5, 7 comes in, okay? So here we go 1 over, and because of you're in half, now we can just say that instead of going 1 up, is going 1 half up. Now, of course, the graph is a different graph, so I can't put in the 0 in there because it generates a different number. But we really don't care about that. We just care about the vertical expansion, or in this case vertical value for the y. So it's now going up by half. All right, the next one will be 3 halves. So I'm going to go over 1 again, because every time you're going to go over by 1, x is 1, we're going to go over by 1, and this time we're going to go up by 1.5 or 3.5, sorry, 1.5 or 3.5, because this is the next pattern is 3 over 2. The next pattern is 5 over 2. The next pattern would be 7 over 2. So I got 1, 2, 3, and then next one again, go over 1, and this time you're going to go up 1, 2.5, which is right there. So these are the coordinates that we got, and I can just sketch this freestyle as accurately as I can. Now I could have added the next one, which is 3.5. So I go over 1 and up would be, that's the half, that would be 1, 2, 3, and sure enough, it's right there. That's the next point. So I was almost there. Here we go. And notice that I take my time to do that. Now, the beauty of it is that once you get to one side, I didn't put in on the table of values the negative values, but it's symmetrical graph, use the axis symmetry and do the same thing to the other side. So that point is there. The next point is here. And the next point is 1 over 2.5. And the next point, 1 over and right there. So, and then the graph, you can connect the graph as well as you can. I'm using a stylus here, but you see what is happening, okay? So that is the graph of y equal to 1/2 x plus 1 all squared minus 2. Everything is included. Now you do need to put the vertex coordinate on the graph. And a couple of other points. So what is that coordinate? Well, that coordinate is 1, 0. What is that coordinate? Well, that's -1, -2, -3. So this would be -3, 0. And that's it. And then maybe on the top will be 1, 2, 3. And 1, 2, 3, 4, 5, 6. So 3 and 6. that would be okay. And that's basically it. So that's good. We got a few points, and that's the graph of that given function.